Okay, so welcome back again. I hope you found the booth viewing useful. I'm delighted to introduce our next presentation. It's really good because we've actually got two perspectives. We've got two great speakers. We have Kiran, who's a senior Scrum Master at Lowe's India, and also Srihari, who's Enterprise Agile Coach at Societe Generale. Uh, the topic of this presentation is going to be, is your code coverage fooling you? It sounds really intriguing, so I shall hand over to Kiran and Srihari. Thank you.
Thank you, Alec. Okay. Hello, everybody. Good morning, and good afternoon, and good evening, wherever you are. Right? It's truly global now. I am Srihari Guru Prasad Thimmapuram. I am an Agile coach with Societe Generale, which is a leading financial service provider in Europe. Uh, I'm also a published author. Myself, Kiran, and one of our friend Vivek have published a book titled Metrics for Agile Product Teams. And today's call is again based on the excerpts that is from this book. So we want to share our experiences. Um, and being an agile coach, I help organizations and individuals and teams to embrace agility to deliver value to their customers. I'm also passionate about technology and enthusiast around technology, and you know uh, passionate about technical agility coaching as well. So that's brief about me.
So hi all, hi Guru. Thank you all for joining. So I'm Kiran, and I'm working as a Scrum Master at Lowe's, and yeah, I'm also a co-author for this book, Metrics for Agile Product Teams. And apart from this, I've also written some blogs, and I love to speak at conferences. And yeah, and that's all about me. And I'm also passionate about badminton. So that's all about me. And coming to this talk, so this is the context. So this is what we are going to talk today. So we'll just discuss what is code coverage, and then we'll also tell you, does the code coverage give you full picture? Should we add another metric to code coverage to measure the quality? And then we'll also discuss what is mutation testing, how it can help, some of the drawbacks what code coverage has, and of course in the last we'll have a few minutes of Q&A session. So yeah, let's start with what is code coverage.
Okay. Thanks, Kiran, for setting that context. Right. So today's topic is around, is your code coverage fooling you? It's all about how measuring code coverage may not really indicate the quality of your code as such. And how does it can fool you, even though if you have good coverage, it indicates good coverage. You may not see the quality of your code as such. So before getting into that aspect, let's first understand what is code coverage quickly, in a layman terms, right? So it's basically, code coverage denotes, it's a measurement of the how many lines of code that is in your source code is being executed by your automated test suite. It essentially talks about the percentage of the code that is covered by your automated test suite. So let's take a simple example to understand. So let's say you have a source code which is being presented here in the slide, right? Let's say you have a source code file which has 10 lines of code, and it has some program which has 10 lines of code, right? And you have an automated test suite which actually verifies this particular program or a function, right? So you have a automated test suite which will verify this. And let's say this automated test suite, when you execute it, it actually executes 3 lines of your code, right? So it's whenever you execute this automated test suite, it's actually executing line 2, line 6, and line 9. So that means it's basically 3 lines of code is being executed by your test suite. So 3 out of 10 lines. So the code coverage will form, it's around 30%, right? It's basically number of lines it is being executed by total number of source code lines that you have in a layman terms, right? So that's about test coverage. What does it denote, right? So what is wrong with, or what does basically what can go wrong in measuring this code coverage, right? How can it may not give the right picture, right, full picture of your quality of code, right? Let's take an simple example to understand how it can fool you, right? How just measuring the code coverage may not actually translate to your quality of code, right? So let's see that. So let's say you have a source code, and which you have a program which actually has a function which actually identifies, given a number, it identifies whether this is even or odd, right? The particular number is even or not odd, and you have a test case written for that. So if you look at this test case, what I am trying to do is, if I am a developer, I have written a test case here. So even or odd, I am passing a parameter 2, and even or odd, I am passing parameter 3, right? So what happens here is, what is the test coverage here? So when I pass parameter 2, the first line of the code that is getting executed, right? So this is covered. When I pass a parameter 3, it goes here, and x3 is 3 mod 2 is not actually 0, so it actually an odd number. The other part of the code is also getting executed. So that means the entire set of code is getting executed with this test. So what is the code coverage? Can we go to next slide? Kiran? So it actually says 100% code coverage, but does it give us the full picture of whether we are testing the actual functionality? No, it just covers the execution of the code, right? So it doesn't verify anything. It just executes the code. It's not verifying anything whether it is even or not. So when we want to whenever we are writing a test case, we need to validate or verify whether the function is actually result function result is actually expected result is or not, right? So that's the part that is missing here. So even though you have not written a meaningful test case, you are getting 100% coverage here. It doesn't validate any of the, let's say, functionality, right? So let's take another example now, right? So we have same function, right? Let's say when when you want to verify something, you use something called assert statements, right? Whether this is valid output or not. So let's say this example, same example, we have a function even or odd, which takes uh, a number as a parameter and identifies whether this number is even or odd. So now that we know that we need to verify something, you did some you did put some rule in your coding practice saying that every test need to associate itself with an assert statement. So let's say the I am a developer, I started writing the code with assert statement, right? So when I wrote this let's look at the second test case that I am trying to write, right? What is happening here is I am just asserting whether it is not null, that's all, right? So when I pass this function, it still gives us 100% code coverage, right? But what's wrong with this is, again, we are not exactly verifying what that function is supposed to do, right? So though we don't have a meaningful test case we don't have, and it doesn't guarantee that the function that we have written is functioning properly, we still have 100% code coverage here, right? So that's the problem. So how can we write correct test cases, right? So what is the correct test case scenario? Let's again take the same example. We have the function to return even or odd, and we are writing another test case which actually validates whether that particular function is returning the expected returns. For example, I am passing number 2 here, so it should return even for me. So that's where I am validating assert equals whether this is even number or odd number. So when it happens, it's actually validating the exact functionality, and this is where we are getting 100% coverage, as well as we are actually validating the correct test case or correct functionality, what our code is doing, right? So that's, so what we essentially saw is, even though we have um good test case coverage, good code coverage, it may not translate to meaningful tests, right? Yeah, Kiran.
So yeah. So just summarizing. So what are the drawbacks? Whatever we observed right now is it only ensures that people are writing tests, right? The code coverage, the number whatever it gives, 70%, 80%, 90%, it only says that we are covering the code, but it need not say that it is measuring the quality of the code we have written, right? That is another drawback. And also it is very easy to write back tests, like you already observed, and we can still meet the code coverage target. So we generally keep a code coverage target, right? We will not push, we will not write any new code until we have 85% code coverage, and those percentages can easily be met. So even though we have observed there is some restrictions put upon us, right? Like we have to make sure we write assert statements, and whatever we do, it can always be faked, because sometimes we have delivery pressure and deadlines pressure, and when these things happen, the code coverage can easily be filled up. And yeah, so it's not only that. So whenever you write a bad test, it doesn't end there. So whenever you execute next time, you have to wait for all these tests to get execute, and those tests may not be even meaningful tests, but you're still running, and yeah, and then there is resource waste. I mean the machines which you have to run your automated tests. So how do we? So the next question is, how do we mitigate this? How do we? Is there anything we can do about this? So there is something called as mutation testing, right? So let's try to understand what mutation testing does. So we understood what code coverage does, and what are its drawback, and and let's try to understand how mutation testing can help us come mitigate that drawbacks. So one is what mutation testing is. What it does is it will deliberately introduce some bugs in your system, in your code, and then your tests will be run again. So let me repeat. It will intentionally introduce bugs in your code, and then your tests will be run. So ideally, if your tests are good, your all tests should fail, because there are bugs that are intentionally introduced, right? So if you have written a good quality test cases, it should fail. If your if the test cases which you have written is not of good quality, it will pass. So that's all the mutation tool does, testing tool does. So it will introduce bugs and run your tests and will give you a report. And it is open source, and it's available for almost all the languages, like React, JavaScript, Java, and yeah. So there are open source available. You can straight away integrate it with your system, right? So let's try to understand with a specific example how mutation testing work. With the same example what Guru had shared earlier. So let's take the same source code here, right? And this is what the source code does. Function, it verifies whether a number is even or odd. So let's say this is the source code, and this is the test which will verify this function. So now what mutation did? So it intentionally introduced a bug, and this is called first mutation. So what it did is, if you observe this xmod 2, it replaced it with x plus 2, right? So now what happens? Ideally, if you have written your test in a good way, this test should fail, right? So if I replace this with x plus 2, so your function, whatever your test is verifying this, it should fail. But what's happening here? Both the test here is passed, because what it does, it's just passing this 2 here, and 2 plus 2 equal to 0, and then return even, or else return odd. So whatever this function does,
Just a
and
5
this,
as promised.
yeah,
Okay.
so we have 5 minutes. Yeah,
Okay.
thanks for the reminder. And similarly, so what it does is, so what this mutation tool does, it will say your mutation is survived. So basically, if your test had failed, it would have told your mutation has been killed, right? So ideally, if your tests are good, your all these mutants would have been killed. Similarly, it replaces this, equal to with less than, and still the, result is same. So now what's happening? So it is giving you an extra picture of how good quality your tests are, right? Now what it tells is, it is 0 out of Q mutations killed. That is 0% mutation coverage, right? Even though the code coverage percent is 100% here, but your mutation test coverage is 0%, right? So what it essentially tells is, the test we have written is not of good quality. So there are many other scenarios which we may not have thought of. The mutation tool is finding it for us, and we can go back and write tests to cover those. So let me just quickly explain, with an example. So this is how the report it gives. So let's say this is your whole code, and this is how it gives. So you have these many folder structures, and for each folder it will give you the percentage of the score, 92%, 70%, right? And in that it will also show how many mutants have been killed, how many have survived, and how many there is no coverage. So it will give you a whole picture. So to understand, so let's go to one particular test file. So I've opened this particular file here. So it will show how many mutants have been killed, how many mutants have survived, how many, how many lines there is no coverage. So one example is, if you see here, there is this, it is showing this as a red indicator, right? It is showing there is this particular mutant which our tests have not covered. So if you see, so what it did is, it replaced this HTTP proxy and made it a null. So it is not passing anything. It is just giving empty. So ideally, your test should fail when this is not passed. So it is telling there is some test case which is not covered here. Similarly, other one. So it is replaced the other one, and then your tests were run, and it will show a report. And it will also show no, the mutants which are killed, which are of good coverage, which are of a good test. So if you see, I just replaced the whole thing, and and passed the, a void here. It did not pass anything. It just passed an empty. So even now, your tests have failed. That means you have written a test case which covers this scenario. So let's say in future somebody comes and, makes this null, right, or removes any of these things. The code will not be allowed to push because your tests will back you up. And that's how, mutation coverage can help you, right? And yeah, so that's all about mutation testing. And what are all the advantages of it? Yeah, Guru, you can give it a shot.
Yeah, sure. Thanks, Kiran. So let's see what are the advantages of mutation testing that Kiran has quickly talked about, right? So it clearly indicates the true quality of tests, right? If you are missing, if your test case is not of quality, if you are just writing test case just to cover up your code coverage, if you just want to write some test case to indicate your code coverage is high, those are the items that you can clearly catch using mutation testing. So it clearly measures the true quality of tests. Yeah. So another advantage is here is, with mutation testing there are there are so many tools available, open source tools, they are of at no cost. So you can integrate your code with mutation testing. These mutation testing tools, they will create mutants, the mutant programs, which will actually automatically run and give you a report. So this is very at no cost you can do it. And another thing that you can actually do is it is easily pluggable into your CI/CD pipeline. So you can add one more stage just to have this mutant coverage testing in the your CI/CD pipeline. It just works that way. So it's easy to integrate into your CI/CD pipeline so that your quality of the code is measured. Okay.
So
So
yeah, go ahead.
in summary, what we have seen is, measuring only code coverage may not really indicate the quality of your code, right? Quality of your tests. It can sometimes it can fool you, even though if you have high quality, high code coverage, you may not have the high quality code, right? So if you complement or in addition to code coverage, if you actually use mutation testing as an additional layer on top of it, right? If you complement with that code coverage with mutation testing, you can quickly validate you how meaningful your test cases are, and you can actually that way you can actually make your code a little more robust with respect to quality, right? So that's essentially what we wanted to cover in this. So I think we are on time for Q&A.
Thank
So
you, Dan.
I'll
Perfect
stop
timing.
sharing. We'll go through the Q&A. Yeah, sorry, I interrupted you, Alec. You were saying something.
Perfect timing. Thank you.
Yeah. Which code coverage is meaningful? Lines coverage, function coverage, and branch coverage. Right. So so it so actually it's all important in its own in its own way. So here we are mostly talking about unit tests, so tests which are at a unit level. I mean, the test which we write when developers actually write code, right? So we are only talking about that here. Line coverage basically. So the question is line coverage, code coverage, and branch coverage. So I don't think it's um it doesn't matter. So in this context, we are mostly talking about line coverage. So I'm not totally sure about functional coverage and branch coverage. Do you mean end-to-end test cases? Is it what you mean in that question? Like functional coverage? Okay. So the next is, how do you manage timelines in implementing mutation testing? So yeah, so one is, yeah, we also have deadlines and we also have timelines. We have to finish some features before the before the time, but implementing mutation testing may sort of slow us down. So this is the common question we have. But the only way to uh, manage is we have to first negotiate with the management, right, about the timelines, because quality is the more important aspect. And another thing is, if we don't fix the bug now, we have to definitely fix the bugs sometime later, and it will add additional cost. So if in terms of spending time, so we'll anyway have to spend time later if we don't think about quality right away. So that's anyway there.
Yeah.
Yeah, Guru, you want
Just
to take up next question? Yeah.
sure. Yes. How do you lead team to start using mutation testing? That's a great question, right? So yeah, whenever we try to introduce mutation testing to the teams, right, the first reaction that we see is yeah, it's you are adding more work to us, right? Obviously, right? Yes, if in a way we are adding more work to the development process, but if you weigh in the advantages of doing mutation testing earlier in the stage, how it can actually help you to identify the edge case tests that you have missed, right? And not clearly written tests that would essentially lead to production bugs, which eventually you may need to rework at the later point of time, which will add more time to your release, rather than taking care of those things earlier in the stages, where you can quickly fix and figure out what's right for your customer. So right, so and another thing that we also look at is you know uh, whenever we are implementing mutation test, yes, initial setup it might take a little more time, but once you are set up with those things required, infrastructure, it's most of the work is done by your tool, right? So that's also there. And whenever we introduce this, and when we did the demo on how advantageous this can be, they in fact the developers, they themselves realized that how they can master their craftsmanship by using this. They found an opportunity to enhance their skill set, and they saw that that could add to their craftsman's repertoire, right? So that way it actually intrinsically motivated these developers, and they started using it voluntarily, so once they saw that benefits.
The next question, although it depends on the nature and complexity of the test, but how does it cost to start mutation testing? So if you already have a test suite, unit test suite, which you already have set up, and you also have set up code coverage, it wouldn't cost you much in terms of it doesn't cost you anything. It is almost zero, because you have the libraries available for basically almost all the technologies. You can take it and implement. And in terms of time, you will have to invest some time and just research. Maybe you can take it in a sprint, or you can just see how it integrates with your code and go from there, because it depends from um, uh, team to team, how well is your code and how much you have to refactor. If you don't have already code coverage and unit test cases, all these things written, it may take more time. Otherwise it wouldn't take much. Mutation testing must have disadvantages to how to overcome them. So one challenges we saw was the we already have some test suite already, which will give you the we already use some libraries to write unit test cases. So your mutation test should integrate with that, and sometimes there is some version which does not integrate, right? So that is one challenge. And another challenge is you'll have to maintain it, right? It's not a one time activity, and as you write more test, or as you write, your code increases, you will also have to cover for mutation testing coverage as well. So it's a constant activity. It's a day to day activity. Which So how do we overcome them is by educating the teams and the management that if it's better to catch the defects early in the cycle, rather than catching the defects once it goes to production, right? The cost of fixing bugs as it moves in the process will be more. So it depends on educating the team and management, if you're a coach or a scrum master.
And also cost of having a production bug is also having an impact on your customer reputation as well, right? So that way you are actually you know uh, saving that phase as well if you are doing something earlier.
Yeah. Mutation testing is expensive where there is stringent budget and delivery time. Yeah, if so, hands up. So if there is delivery timelines and stringent, so you can't do much about it. So unless the management is not ready to negotiate about quality, we can't do much about it. So yeah,
Yeah.
but yeah, we have to. That's another discussion. How to bring in the management, the team, into thinking about quality and negotiating timelines. So that's again totally another topic.
Yeah.
What are some of the assumptions made?
We've just got 1 minute
um,
left, so there may be
Yeah,
time, I think, to answer this last question.
yeah. What are some assumptions made? I didn't get that
get
answer.
the
So some
question. Yeah.
assumptions is, uh, so one assumption we have is it will try to come up with scenarios which we didn't think of, right? So that's one assumption we believe. So as you saw, it replaces your code with something else, but we think it will almost replace with all the scenarios, but that may not be the case. But yeah, there are some basic things it will do, like changing it, making it null, or removing all the whole data, or Yeah, that's the assumption we have,
Yeah.
but I'm not sure if I answered that right.
So actually mutations you can do it in three ways. If you look at it, right, you can when you create mutants, it basically it replaces the value. It can also replace the logical operators. It can also replace the entire statement also. That way, you are actually ensuring the logical business rules also covered. So your assumptions around business rules also will you will uncover some of these things in when you run this mutation testing.
Thank you.
Yeah, I think it's time. Yeah.
That's perfect timing. We're spot on. So thank you both very much. Great presentation. And again, thank you to our audience for some really good and thought-provoking questions. So we'll move on now to the next session, and we obviously we've got the panel, so we'll welcome you back at the end of the day as well. So thank you. We'll go to the next presentation. Thank you.
Thank you, Alex, for the
Bye.
Thank,
opportunity.
Bye.
Unicom.
Thank you
thank
very
you,
much.
everybody.
Bye.
Thank you, Alex, and for
Bye.
the opportunity. And it was nice speaking to you all.